So now let's do the second part of 13. This is g of x equal to sine of x times cosine of x on the interval from 0 to 2 pi. I'm only giving you from 0 to 2 pi because otherwise there would be infinitely many critical numbers, because this is a periodic function with period 2 pi. And so if you have a critical number at one number, then you're going to get a critical number at every at plus or minus 2 pi times every whole number of that number where you get a critical number. So anyways, let's take the derivative. G prime of x is equal to my whatchamacallit rule, the product rule. Tells me I take the derivative of sine, which is cosine, I multiply by cosine, great, and then I add sine times the derivative of cosine, which is negative sine, so I'm putting a negative there. Derivative of cosine is negative sine. And so maybe a pretty way of writing this is cosine squared of x minus sine, wow, that looks really bad, sine squared of x. And is this ever undefined? No. Cosine is always defined, sine is always defined, so I don't have to worry about this being undefined. So the only thing I'm worried about is when this is equal to 0. How do I solve this? There are a variety of ways of solving this. One way is to use, say, a Pythagorean identity to rewrite cosine squared in times of sine, or vice versa. We know that sine squared plus cosine squared is equal to 1. This looks a little different, cosine squared minus sine squared. We don't have an identity which says what that is, but that's okay because we're trying to solve this thing. Another way that I think of doing this is, I don't know what that is, oh, that was an equal sign, whatever, is to add one of these guys or subtract one of these guys to one side. So I'm going to subtract, actually I'm going to add, no, I'm going to subtract cosine squared from both sides. No, I'm going to add sine to both sides. Add sine squared to both sides. And I get cosine squared of x is equal to sine squared of x. Okay. You really might be tempted to take a square root here, and I suppose that's fine. That would tell you that cosine of x is equal to plus or minus sine of x, but that's a weird looking sort of trig equation. Why don't we try this? I'm going to divide both sides by cosine squared. Why would I think about doing that? Because sine over cosine is equal to tangent. So this gives me 1 is equal to tangent squared of x. Okay, so now I've got this down to a single trig function. So now I'm trying to solve tangent squared of x is equal to 1. And taking square roots, I get tangent of x is equal to plus or minus the square root of 1, which is plus or minus 1. So now I've got to say to myself, where on the interval from 0 to 2 pi is tangent equal to plus or minus 1? Well, I know one place that tangent is equal to 1, which is when I have my isosceles right triangle, and that happens when the angles here are 45 degrees, or pi over 4. So one place is when x is equal to pi over 4. And also, since tangent is periodic with period pi, it also happens at pi over 4 plus pi, which is 5 pi over 4. That's when tangent of x is equal to 1. When is tangent equal to negative 1? Well, I know that happens when x is equal to negative pi over 4, because tangent is an odd function. Tangent of minus x is equal to minus tangent of x. But I don't care about minus pi over 4 because that's outside of my interval. However, by using the period of pi, I can add pi to this expression and get 3 pi over 4. That's another place where tangent is equal to negative 1. And adding pi to this, I get 7 pi over 4. And this happens when tangent of x is equal to negative 1. You can check everything else in this interval, but between 0 and 2 pi, the only places where you will end up with tangent equal to 1 or negative 1 is going to be any place where you have a fraction with something times pi over 4 in lowest terms. And these are the only guys that are fractions of pi over 4 in lowest terms between 0 and 2 pi. Those are the only places. It's right here, right here, right here, right here. This is pi over 2. This is pi over 2. This is 3 pi over 2. And these are the numbers that we just wrote down over there. Pi over 4, 3 pi over 4, 5 pi over 4, and that one is 7 pi over 4. And that's it. Great, so those are our critical numbers. Great. Notice I don't care about where tangent of x is undefined because that has nothing to do with our original equation. Our original derivative was cosine squared minus sine squared. That was always defined. The only reason we introduced tangent was in order to solve this equation. Great.